So how is this bauxite ore concentrated? Let's see this method. Okay, we'll first study the Bayer's process and then we'll study the Hall-Herold's method, the Hall's method. Okay, in Bayer's process, the ore is first ground or powdered in a ball mill. Okay, it is first nicely powdered or grounded. No, it is nicely ground, and then it is leached by heating with concentrated aqueous solution of caustic soda under high pressure for 2 to 8 hours for 2 to 8 hours, I should say 7 to 8 hours at 140 degrees Celsius to 150 degrees Celsius in a tank called digester. There's a tank called a digester, and okay, and in that what do? They take this bauxite ore and they heat it with concentrated sodium hydroxide. And this is a leaching method. What is leaching method? We saw a leaching method is a method in which the mineral dissolves, no, in that chemical, whereas a gangue does not dissolve. Okay, so we'll see this aluminium oxide. Now, what does bauxite ore contain? Bauxite ore contains aluminium oxide. Remember, and which are the impurities in that? The aluminum oxide is a actual what we need to remove. But along with aluminum oxide, there is iron oxide and what? Silicon dioxide, no, or SiO2, silica. So silica and iron oxide are the impurities, whereas I am interested only in the aluminum oxide. Now aluminum oxide being amphoteric in nature. Okay, what is amphoteric nature? An oxide which can form, which is acidic also and basic in nature. It is both amphoteric. It is both acidic as well as basic in nature. Like you have amphibians. Remember what are amphibians? Animals which can live on land and in water. So also, what is aluminum oxide? Aluminum oxide is an oxide which is amphoteric. Amphoteric means it is acidic also in nature and basic also in nature. So since it can be acidic in nature, since aluminum oxide is amphoteric, so what happens? It behaves like an acid, and it reacts with sodium hydroxide solution to form water soluble sodium aluminate. So with sodium hydroxide solution, it behaves like an acid or an acidic oxide and gives you water soluble sodium aluminate. That's what I told you. What is leaching? In leaching, what happened? I told you the main ore, what we are interested in, that gets leached or gets what you call dissolved in the particular liquid or in the solution what you're using for leaching. So this sodium aluminum oxide reacts with sodium hydroxide and forms sodium aluminate, and this sodium aluminate gets dissolved in this sodium hydroxide in that solution. So let's see this thing. The aluminum oxide plus sodium hydroxide giving you sodium aluminate, NaLO2, and water. Now what happens to the iron oxide? The iron oxide which is there in the gang means kachra. I told you one of the kachra is iron oxide. The iron oxide does not dissolve in the aqueous sodium hydroxide and is removed by filtration. So you filter it out. So what happens? Since it does not dissolve, the iron oxide does not dissolve, it can be removed by filtration. Okay, like how you know when you want to filter your chai, you pass it through a sieve, chalni, so all the tea powder gets stuck in the chalni and the tea comes out through through the sieves, through those pores, something similar to that. However, there's one problem here. The silica, which is there, no, silicon dioxide, SiO2, that which is also kachra, that also gets dissolved in the sodium hydroxide along with the aluminum hydroxide. Along with the aluminum hydroxide, the silica, or you call it silicon dioxide, also gets dissolved in the sodium hydroxide, forming sodium silicate. Now this is a small problem we have. So we managed to remove the iron oxide because it did not get dissolved in the sodium hydroxide. We removed by filtration, but the problem is along with the aluminum oxide getting dissolved, the silica also got dissolved and formed sodium silicate. Okay, so silica also will react with sodium hydroxide and form sodium silicate. Here aluminum oxide reacted with sodium hydroxide to form sodium aluminate. Here silica or silicon dioxide reacted with sodium hydroxide to form sodium silicate. So let's continue. We'll see how we can get rid of this silica or the sodium silicate. Now this aqueous sodium aluminate is then diluted with water and cooled to 50 degree Celsius. Now what happens when you cool it to 50 degrees Celsius? It gets hydrolyzed. Hydrolyzed. So since we are adding water, the water will hydrolyze it. Okay. So when you pass electric current, what happens? It gets electrolyzed. It gets electrolyzed. So also when you are adding water, it gets hydrolyzed, and that sodium aluminate gets hydrolyzed to form aluminum hydroxide as a precipitate. Precipitate means something which settles down. Like when you put some sand in water, what happens to the sand? The sand will settle down. Okay. So like for example, if I put tea powder in the tea, there's tea powder in the tea. Where will the tea powder go? It will go and settle down. So so it is diluted with water. So aqueous sodium aluminate will be diluted with water and cooled to 50 degree Celsius. Remember the temperature was 140 to 150 degrees Celsius. So I'm cooling it down. And they also now see direct hydrolysis doesn't happen, boys. Okay. Now if you put anything in water, will it get hydrolyzed? No. You have to add a few drops of dilute HCl. Okay. You have to also add that, which is not mentioned in your textbook. It is also some HCl or hydrochloric acid. A few drops of hydrochloric acid is also added to the aqueous sodium aluminate for the hydrolysis to take place. So now finally we have got what as a precipitate? Aluminium hydroxide as a precipitate. So precipitate will settle down. So sodium aluminate plus water gives us sodium hydroxide and aluminium hydroxide. Now can you see the downward arrow? Downward arrow stands for what? Precipitate. We learned in that lesson number 3, in that chemical, where we learned about different types of chemical reactions. Now this is the Bayer's process. Now we go on to the Hall's process. In the Hall's process, what we do? The ore is powdered and then leached by heating with aqueous sodium carbonate. In the Bayer's process, we heated with aqueous sodium hydroxide. In Bayer's process, we heated with aqueous sodium hydroxide. In Hall's process, we heat with aqueous sodium carbonate. In the digester, in that same tank, like a digester, to form water soluble sodium. Here also I am getting water soluble sodium aluminate. In Bayer's process also, when I heated with aqueous sodium hydroxide, I got water soluble sodium aluminate. In other words, the sodium, the aluminum oxide reacts with sodium carbonate and forms sodium aluminate, and this sodium aluminate gets dissolved in the solution. Then as usual, as I told you, this iron oxide, those impurities which are there are what has happened? They are filtered out. The impurity which don't get dissolved, they are filtered, and this filtrate is warmed and neutralized by passing carbon dioxide gas through it. So what is passed through it? Carbon dioxide gas. Okay. This results in the precipitation of aluminium hydroxide. So what happens during this process when you pass carbon dioxide gas through this filtrate? What does this filtrate contain? This filtrate contains sodium aluminate. So when you pass carbon dioxide gas through sodium aluminate, aluminum hydroxide gets precipitated or it gets settled down. नीचे जाके जम जाता है. So let's see the reactions. So aluminium oxide reacts with sodium carbonate. First reaction. This can you see this? Follow the laser pointer. This step. Aluminum oxide reacting with what? Sodium carbonate to giving you sodium aluminate. So here sodium aluminate. Can you see sodium aluminate here to form sodium aluminate? Then we filter it and all that, and then we pass. It is warmed or slightly heated, or warmed, but it is slightly cooled, and carbon dioxide gas is passed through it. The sodium aluminate plus carbon dioxide giving you aluminum hydroxide. Again, can you see a downward arrow here? Downward arrow means it is a what? Precipitate. So in both this reaction, the Bayer's process I saw also, if you remember, I got aluminum hydroxide as a precipitate, and the Hall's process also I got aluminum hydroxide as a precipitate. In both this process we get the same thing. So what is the main difference between the Bayer's process and the Hall's process? In Bayer's process, if you remember, the ore is heated with aqueous sodium hydroxide, whereas in the Hall's process it is treated with aqueous sodium carbonate. Understood the first difference? Second difference, in Bayer's process the sodium aqueous sodium aluminate is diluted with water and hydrolyzed to give aluminium hydroxide as a precipitate. Follow the laser pointer. Okay. So in Bayer's process, second difference, in Bayer's process, the aqueous sodium aluminate is diluted with water and it gets hydrolyzed to give aluminum hydroxide as a precipitate. Whereas in Hall's process, the aqueous sodium aluminate is what? How do you get aluminum oxide precipitate? The you pass carbon dioxide gas through aqueous sodium aluminate and you get a precipitate of aluminium hydroxide. So I hope it is clear. So here first, so I hope the difference is clear between the two process. What is the process? That other process was what? It was the Bayer's process, and this is the Hall's process. Bayer's process, I use aqueous sodium hydroxide. In Hall's process, I use aqueous sodium carbonate. In Bayer's process, I add water and hydrolyze the sodium aluminate to give me aluminum hydroxide. In Hall's process, I pass carbon dioxide gas through the aqueous sodium aluminate to give me aluminum hydroxide as a precipitate. So I hope this is very clear, boys. So let's continue. Then finally what happens is the precipitate of aluminum hydroxide obtained in both the Bayer's process and the Hall's process is filtered. It is filtered, washed by filtered. If there is still some kachra and all, it is filtered, washed, dried, and calcined. Calcined means calcinated. Remember I told you in the first slide. Okay, in the first slide of extraction aluminum that it will be calcinated, calcined by heating at 1000 degrees Celsius to get alumina. Okay, so it is heated to 1000 degrees Celsius. What is calcination? Calcined means what? We use very less supply of oxygen or a very limited supply of oxygen. So without oxygen, of course it will not. You need oxygen. You need oxygen, but just for burning, just enough for burning. So it is calcinated or calcined by heating at 1000 degree, and finally you get aluminium oxide. What you need. Okay, so this whole process, this concentration was to remove the ores. So which ore we managed to remove? We for which what do you call which impurities we have managed to remove? Which are the main impurities with the aluminum oxide? If you remember in the beginning, which impurities were there? Iron oxide and silicon dioxide. That is iron oxide and silica. So we removed all that, and finally we have got our aluminium oxide, that is alumina. Now this alumina is then reduced to aluminium by using electrolytic reduction. Now we will do the second method. Now this is the first process. Remember, in metallurgy there are three processes. One is concentration, second one is isolation or what you call reduction, and third process is refining. Okay, so we have finished the first process for aluminium. Now we will go to the second process. How we can use electrolytic reduction to reduce the alumina. To reduce the alumina to aluminium. What is alumina? Alumina is nothing but aluminum oxide. No, aluminum oxide has to be converted to aluminium. That, in other words, reduce means the oxygen has to be removed. The oxygen has to be removed from it. So we'll see how it is done in the next slide.